Lockheed Martin is a leading technology and aerospace company. Space Systems is one of the divisions within Lockheed Martin that focus on a variety of space technologies. Satellites, rocket technology, and even technology for human spaceflight to get humanity to Mars. With the degree that technology is advancing, we need to keep up and be ahead. And the only way to do that is to rapidly iterate, have new ideas, and deliver that to production.
In our printing lab right now, we have almost the entire range of MakerBot's offering, from the Rep 2 all the way to the Replicator Plus. We can tailor fit every single piece of our lab hardware to be what we need it to be. Optical rings or fitments or baffles. When I go through and have to arrange my build plate, I just click the button and MakerBot print. It figures it all out, and I have my parts a couple hours later. Spider is a different way of taking a picture. If you actually look here, this is really long and really big because it needs a large focal length. When you have a smaller lens, you don't need as large a focal length. We kind of can shrink the telescope down and have a bunch of set of apertures that help stitch together a bigger picture. Lockheed Martin is doing a lot lately to become very lean, very agile, very efficient. Things like integrating additive manufacturing at all levels, from R&D to a final product. Printing helps us with that because I can be the design role and the manufacturing role.
For space-based systems, optical payloads are very expensive. And if you could get rid of the telescope, then you could get rid of substantial size, weight, and power that's required to put an optical imaging system in orbit.
3D printers like MakerBot really enable rapid iteration of ideas. If we can create a really reduced optical payload that can be small enough to be hosted on a satellite that can host other payloads, that's a real game changer.
Spider is like the cutting edge of everything. People think it's impossible, and I think that's one of the coolest things. We're working on these designs that last year after year, and maybe there's 3 or 4 years of R&D to even get a working prototype together. But we're pushing something out the door that's beyond what most people even think is a reality.